Why should you listen to me? I've been on various functions in operations, from shop supervisor all the way to CEO of an aircraft company. And I've seen the enormous opportunity that exists in using shop floor data. Currently, there's all these studies out there that show that less than 10% of data in a factory is actually used to improve the factory. It's just sitting there. Nobody knows how good it is. Nobody knows what is sitting there, how to utilize it, particularly for small and medium-sized companies where you don't have an army of engineers or IT people. So that's where we come in. Then you have a lot of companies that use custom dashboards that you're using from ERP, downloads of how the things are doing, how the last month went, what were your revenues, what were your on-time delivery, what were your metrics, and so it's a static dashboards looking at ERP system. So obviously that's descriptive, telling you as is, but not what's predictive and what's going to happen into the future.
Rapid scenario analysis allows users to build complex what-if scenarios. When combined, users can compare long-term planning strategies. Let's explore a bottleneck mitigation use case. Start by identifying periods of red.
So this is a simple way, a heat map to show where your bottlenecks are. So on the y-axis, you have all your resources, whether they are labor resources or machine resources. And on the x-axis is time. So imagine you are in January 2024, and you are looking ahead 18-24 months to see where your bottlenecks are likely to be. And this demo is going to show you how to handle that.
These areas indicate a bottleneck. We can see two issues with this factory. In spring of next year, Factory Twin is predicting a bottleneck across many resource groups. We can also see that this CNC operator group is chronically constrained throughout the next year and a half. Let's focus on mitigating the CNC operator group bottleneck using rapid scenario analysis. First, we'll experiment with a brute force method of bottleneck mitigation. Start by creating a new simulation. Add one more CNC machine to the Minneapolis factory. Choose the date it would become available to production. Next, hire 3 new CNC operators for the Minneapolis factory. Choose their hire date. Each operator will be assigned to a different shift. Save and build this simulation. Compare the baseline simulation with the brute force scenario. When we compare the baseline factory with the brute force scenario, we can see that the CNC group is no longer constrained. Adding new resources comes at a high cost, so we may want to explore other options. Next, we will try a more cost-effective approach using existing resources. Let's go back to the original state of the factory. Notice how the saw labor group is consistently underutilized. Additionally, we can investigate the demand drivers of CNC utilization. Notice how there are 3 customers' demand driving the utilization. Create another simulation. First, cross-train the underutilized saw operators for CNC tasks. Then, level load demand for the customers driving CNC utilization. Adjust line item due dates to smooth out the demand spikes. Lastly, add overtime to each shift. Save and build this simulation. Compare the baseline factory with this cost-effective scenario. With this method, we've eliminated the CNC bottleneck. Both of these scenarios resolved the CNC bottleneck. However, the cost-effective scenario is more practical and affordable than the brute force scenario.
So I'm going to give you now an example of video of a bill of material explorer. We call it know your shop and know your parts, because that's the first thing that people have confusion about. What components go in what. If you have reasonably complex bill of material and routings, nobody knows what really is going on in the shop, or some people do and most of the people don't. So here is a good way.
Factory Twin's Bill of Materials Explorer shows you the BOM trees for every part made or bought in your shop. In this depiction, blue nodes are purchased parts and red nodes are finished goods. Clicking on a part gets you everything you need to know about it. Let's start with a finished good part. Factory Twin's on-demand value stream map is based off of historic work order data. See a part's percent value add ratio and identify opportunities to improve lead time in a matter of seconds. Analyze the Pareto and spread of historic production times for each step in the route. Particularly high or variable distributions are great opportunities for improvement. Investigate the part's future demand patterns to see if level loading is possible, and see what future bottlenecks will affect this part's delivery. Next, let's investigate a purchased part. Select a part of interest. Review current data gaps related to the part. Addressing critical gaps is crucial for data health and insight accuracy. Track the historic delivery performance of the material's various suppliers. Observe how the material's unit cost has changed for each supplier, and compare unit costs if there is more than one supplier. You can do future planning for each purchase part by understanding the consumption points and order points based on lead time. This also gives you future inventory exposure.
Things that people don't realize, that if you're going to use digital or data, having confidence in data is not only imperative, it's also very time consuming. And usually a data analytics project can take about 50% of its time in just understanding and building confidence in the data. So we have built some automated tools. There's one called Factory Validator, which goes into all operational sources of data and checks for gaps and consistencies. And it does it automatically. So that's a one-of-a-kind product. No other software company I've ever heard of has that for manufacturing. But it's a very good way and very useful tool for our customers to not have to go and check everything, one at a time, where you have thousands and thousands of fields to fill out.